Good afternoon, Rich Nass, Executive Vice President with Open Systems Media, here with Colin O'Flynn, who is the CTO of NewAE. He has a pretty cool security product that he will be briefing us on now. Hello, Colin, how you doing?
Hey, not bad, Rich.
So what exactly do you have here that you want to share with our audience?
Yeah, so we have this product called ChipWhisperer, which is actually pretty interesting. I mean, I think it's interesting, of course. It started as an open source project. There was actually a Kickstarter to make this really low cost hardware for doing side channel power analysis and voltage fault injection and clock fault injection. So the ChipWhisperer solution is a combination of hardware and software. I have some examples of the hardware down here. So this is, for example, like a board that lets you record power traces from a microcontroller. So when I say a power trace, what that means is as the device is doing different operations, it actually gives you sort of different visualizations you can see in how much power it's using. So this is pretty interesting because it turns out a lot of security, so like password checks, crypto checks, AES algorithms actually leak a little bit of information about what the device is doing and the data device is processing based on the power it's using. So I can show you a little example here. If we look at like some of the, so this is also open source. So if people are interested in checking it out, this is what we call these Jupyter notebooks, which is like this Python interactive method of going through and looking at how the actual attacks work. So for example, one of the attacks is power analysis and using this to bypass a password. And what you basically have is like, as the device is running, you can actually see small variations in the power consumption of the device. So right here, this is like orange is the power consumption with the correct password or incorrect password, I forget offhand, and blue is with a correct password. You can see there's this point in time they diverge, and it actually tells you if the device is programming the right or wrong password. So this is important because if you're evaluating a device, like if you're looking at devices and wondering, how well does the code read protection work or things like that in them, you really need to be able to, either understand the vendor claims or perform your own analysis. And it also might be that if you're working on developing your own security solutions, what you need is a way to actually run these tests yourself, right? Because if you're claiming that you have some secure library, it's important to understand how the attacks work. And it goes all the way up to a lot more advanced attacks. So something called correlation power analysis, for example, allows you to actually break a crypto implementation. So in a similar way, what we can do is we can actually look at how much power a device is using to understand what data is being processed, and from that recover stuff like a secret encryption key being used by the device. So that's kind of on a really high level. Our products are all around this, are around helping people understand and test what the actual device is doing, and helping them understand and test, how can I actually test my own products against this. So some of the other courses too, and so I've talked a lot about side channel power analysis. The other interesting thing is fault injection. So there's a number of examples of this for bypassing device security. So you might have heard about some devices. For example, this is one particular vendor. There's not vendor specific at all, but basically it comes down to there's some sort of test of like, is a fuse byte set to a certain value or not? And with fault injection, we're actually corrupting the read of that value. So this is another thing that is really critical if you're developing secure products that you want to test your products against. So yeah, that's kind of as a high level what we try to help people do. And as an example of how easy this sort of stuff is, it's not just an academic lab type environment where these come up. Let me run a power analysis for you. So what I'm going to do on the hardware side, there you go, is there's a few different ways this can work. So let's go to a bigger screen here. There you go. So this board here is part of our, this is part of our ChipWhisperer platform. It's actually sending data to the target device. In this case, like a microcontroller running, I believe this is with either TinyCrypt or embed TLS. I forget which crypto implementation I'm running right now, but you basically have different crypto implementations you can test through. And this device is going to send data to the target device. The target device is going to encrypt it and then send that data back. At the same time, we're going to monitor the power consumption of the device. So we then use this kind of like an oscilloscope, right? This is basically just designed to be a little lower noise than an oscilloscope. And what it does is it helps you monitor the power consumption that we can then run the analysis on. And I can do the same thing on this other board here. So this board is a board where you'll notice the left half of it looks the same. The right half of it just has a little built-in target as well. So this has been really good for running tests where you want to learn about the fundamentals without running on a particular device you care about, just running on any sort of device. There's been a lot of interest in this, you can imagine, with education around the area, especially kind of remote education where you can have everything on one board. So I'm going to leave this one plugged in to test. And what you'll see is if we leave that up, I can bring myself back up here. We can say that we're going to run this on a certain type of device. So this is, again, is all open source, and what it's going to do, it's going to compile some firmware that's going to run on the device. And this allows us to test, like if you wanted to try a different crypto implementation, we can really quickly just change that. It's going to program the device and record these power traces. So the power traces look something like this, just to give you an idea. And what you're actually seeing is the power consumption of the device as it's running part of AES. And AES really quickly runs in multiple rounds, so you can actually see some repetitive nature to this power trace here. So this is the first round here, followed by the start of the second round, and that'll go on. And so you saw that only took a few seconds, like it recorded 50 traces or something like that. We tell the system about the fact that we're running AES. The interesting thing is we don't have to tell it anything about what library we used or whatever. It's just the basics of, hey, this is running AES. It will then run this attack called a correlation power analysis and hopefully pop out the what the correct key is. So what we've tried to do is we've actually, because we're concentrating on helping people understand this example I have up here goes through how the actual entire attack works. So you'll notice that I'm kind of going through, in this example here, the actual fundamentals of it. So we have a second one, which just runs, you don't have to think about it type attack, but you can see there's quite a bit of work that's gone into helping you understand this. And it's going to guess the correct key. So in this case, we have 1 byte of the key, and it only takes a few seconds to guess that correct byte. If you wanted to guess the whole thing, this little block here, you can see it's only going to take a few seconds to run, and this is going to guess 16 bytes of the key. I happen to know, so I programmed the key in this device so that I know that's in fact the correct key, and you could check that. But that's just one of the many types of tests you can run with the ChipWhisperer. We've concentrated a lot on making as much of it accessible as possible. So you can see I've gone through all this software here. And we also have some hardware solutions that are low cost, some that are higher performance, and a lot that are also open source. So you can take a look at some of the hardware designs yourself.
Very interesting. Is there any concern that it being open source, sometimes people don't put open source and security into the same sentence?
Yeah, which has been an interesting thing. So when we started this, a lot of people were doing this work. So the interesting thing about these actual attacks we use is they were first openly published in 1999, right? So they're not new. And one of the things we saw is a lot of customers would say, like, or not our customers even, but other people's customers would say, like, oh, these attacks are unreasonably difficult to do. And I just showed that you can run one of these attacks in kind of a few minutes, even with this really basic system. And so what we're trying to do by pushing it open source is say, like, these are a real threat. People can do it now. It's a little complicated. Sure, it's maybe not the first thing you'd look at. But if you want your embedded product, right, it's going to be out there for 20 years, 10 years, maybe just 5 years. Then you probably want to think about what attacks are going to be the most prevalent there. So part of doing it open source has been a big point to sort of make it more accessible, right? It's also great for students and work like that as well, where they can extend it themselves or push changes to it.
That's great. Where can somebody go for more information?
So we have our website at newae.com, has links to quite a few of this material, as well as starter information and sort of everything else you need to know to get started.
Awesome. Thank you very much, Colin.
Thanks so much, Rich.